In question 1, a boy throws a ball vertically upwards and lets it fall to the ground. We have a displacement time graph for the ball. In A part 1, we need to state which feature of the graph gives the velocity. Well, the gradient of a displacement time graph gives velocity. In part 2, we have the axes of a velocity time graph, with times t0 when the ball is thrown, t1 where the ball reaches its maximum displacement, and t2 where the ball reaches the ground, marked. We need to draw a shape of the velocity time graph for the ball between t0 and t2. Well, here are the axes, and we have the starting point x here. In part 2, we have these axes for a velocity time graph, with t0 the time when the ball is thrown, t1 the time when the ball reaches its maximum height, and t2 the time when the ball hits the ground, marked. We need to draw the shape of the velocity time graph for the ball between t0 and t2. This is the starting point x. Well, the velocity will gradually reduce to 0, then increase in the negative direction. The gradient of the velocity time graph gives the acceleration, and as this is constant, the line is straight. In B, we have a diagram showing the ball deforming as it contacts the ground. In part 1, we need to explain how Newton's third law of motion applies to the ball at this point. Well, the ground exerts a contact force upwards on the ball, and the ball exerts a contact force of equal magnitude downwards on the ground. In part 2, we need to explain why there is a resultant upwards force on the ball. Well, the upwards contact force from the ground is greater than the downwards force due to the weight of the ball. This produces a resultant upwards force.